Welcome to this explainer. Let's start by taking a slow, steady breath. In and out. Go ahead and settle into your space. If you're looking at your screen, you'll notice we're working within a completely clean, minimalist, dark mode digital tablet interface today. The focus level indicator is at 100%, and we've got some soft, rhythmic, lo-fi study beats tracking underneath our thoughts. Today, we are going to strip away all the noise, all the clutter, and completely deconstruct one of the most notoriously intimidating topics in the Cambridge AS and A-Level Mathematics 9709 syllabus. We're talking about Newton's laws of motion concerning connected particles, pulleys, and towbars. Now, joining us in our shared digital workspace today are two of our top scholars. We have Alex, who is incredibly analytical and highly precise, and we have Sam, who brings this brilliantly creative and dynamic energy to problem solving. Together, the three of us are going to map out a serene, structured blueprint of exactly what the examiners are looking for. By the end of this session, we won't just understand the mechanics, we're going to figure out how to view every complex question as a calm, predictable puzzle. So let's get into the zone. 15%. I want you to really internalize this metric right now because it is literally a game changer. It completely reframes our entire approach to the paper. In paper 2 of the mathematics exam, connected particles, pulleys, and towbars account for approximately 15% of the total marks. Now, I know for some, that's a massive margin that might induce a little bit of panic. But in this space, we don't do panic. We look at that number as an incredibly high-yield opportunity. It's a gift. Because when we systematically master the standardized process for this single topic, we are effectively securing a massive chunk of our overall success in one fell swoop. We are turning anxiety into absolute, calculated strategy. It's just a process, and we are going to master it right now. Okay, let's dive into this serene roadmap we've built for today. First, we'll look closer at the 15% opportunity. Then we'll move into mastering the core principles. After that, we'll unpack the method mark strategy. Fourth, we'll navigate the examiner pitfalls you absolutely need to avoid. And finally, we'll wrap up with a systematic recipe recap to lock it all in. Section 1. The 15% opportunity, turning anxiety into strategy. The very first step to turning your exam anxiety into a calculated winning strategy is acknowledging exactly what is actually being tested. If you look at our digital workspace, you can see I'm using a clean highliner right now to calmly peel back the filler words in the syllabus quote, isolating the exact assessment objectives. It says, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Notice how I'm highlighting the words conceptual understanding and unfamiliar contexts. Cambridge isn't just testing if you can memorize the formula for tension or remember that force equals mass time and acceleration. They are testing the architecture of your mind. Let's look at how our scholars handle this. Alex is typing out a perfectly structured paragraph plan, focusing purely on the analyze command word, breaking down the formula. But Sam is bringing in the evaluate command word, reminding us that we need to build adaptable mental frameworks. The examiners don't just want to see if we can solve the exact pulley setup from a textbook. They want to see that whether they throw a smooth inclined plane or a rough horizontal towbar at us, our conceptual understanding remains deeply, unshakably rooted. Section 2. Mastering core principles, the theoretical architecture. To build this beautifully adaptable framework, we have to look at the theoretical architecture holding these connected particle problems together. The conceptual framework is defined as the integration of systematic analysis and evidence-based reasoning within Newton's laws of motion. Now, what does evidence-based reasoning actually mean when we're just staring at a diagram of two boxes attached by a string? Let's check in on our scholars' shared digital workspace. They're assembling a model response paragraph right now. I can see Alex mapping out the textbook definitions step by step on the screen. Alex is highly precise, but right now they're crowding their page layout with unstructured facts. Sam steps in and challenges the framework, pushing to include a clear, logical evaluative link back to the prompt. And Sam is right. Evidence-based reasoning means every equation we write down must be justified by the physical forces. We calmly isolate each particle. We identify the evidence, like gravity acting downwards as mg, the normal reaction, or friction-resisting motion. And then we base our mathematical reasoning entirely on that isolated evidence, writing out our sentences live on the screen to perfectly fit the mark scheme parameters. These core architectural elements are what make the entire system breathe and function. First up, precise definitions. We have to know our terminology cold. Second, causal relationships. This means understanding exactly how a driving force applied to particle A creates a uniform acceleration that physically affects particle B through the tension in a connecting string. It's a chain reaction, and you have to see the flow. And third, cross-topic connections. This is absolutely crucial, guys. Principal examiner reports reveal a fascinating trend year after year. Candidates who seamlessly integrate concepts from kinematics, like the v squared equals u squared plus 2as equation, or those who bring in basic trigonometry to confidently resolve forces parallel to a slope, achieve significantly higher marks. It's all connected. It's like a giant, beautiful puzzle. Section 3. The method mark strategy, rewarding the process. Okay, let's breathe and refocus for a second. Before we write out our final top band paragraph structure and walk through this incredible method mark strategy, I want to make sure your daily study dashboard is complete. So I need you to subscribe to Ace the Exams, that's at Ace the Exams, right now, and enable all notification alerts. On your screen, you'll see a clean, minimalistic graphic of our notification bell lighting up. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free, deeply focused exam mastery. All right, back to the strategy. This is perhaps the most calming realization you can have today. Cambridge actually rewards the process. We aren't just graded on a flawless final answer. We are rewarded for the logic of our journey. So let's establish a flawless, reliable rhythm for every past paper using this 5-step sequence. Step 1, identify key elements. Calmly extract the masses, the angles of the slope, the coefficients of friction. Step 2, apply relevant principles. Draw clean, perfectly straight free body force diagrams. Step 3, execute analysis with clear working. Resolve those forces vertically and horizontally using F equals ma. Step 4, verify your results. And Step 5, present in the appropriate format. Establishing this exact flow lowers your anxiety instantly and builds an incredible safety net of method marks. Now, looking at the shared digital workspace, it looks like Alex and Sam have just hit a structural roadblock mid-paragraph. Their evidence has kind of dropped out of alignment because they lost focus on the conventions. So let me step in here and provide a clear visual structural framework. We're going to use the PEEL structure, point, evidence, explanation, link, to calmly restore balance to their text. The crucial point here is that strict conventions are completely non-negotiable. Proper headings for different parts of the system, correct mathematical terminology, appropriate formats, and incredibly clear annotations. Our scholars are now writing out the response out loud, line by line, creating a pristine, high-scoring block of text. If an examiner can effortlessly track how you resolved a force parallel to a plane because your annotations are beautiful and structured, you secure those vital method marks. Even if a tiny, stressful arithmetic error occurs at the very end, your structure protects you. Section 4. Examiner pitfalls to avoid, navigating the traps. I want to open up our live interactive practice arena now. Let's pause intentionally and consider this question on the screen. Why do students find interpreting complex texts and data so hard under exam conditions? It's almost never a lack of mathematical ability. It's usually a breakdown in structure. When panic sets in, a complex paragraph describing a car towing a trailer up a hill feels like a massive threat rather than a predictable puzzle we can decode. So let's do challenge 1 in our practice arena, the mindful scan. On your screen, you'll see a highly complex Cambridge source chart detailing connected forces. Right below it, a minimalist circular graphic is starting a 60-second visual countdown timer. As that timer ticks down, your goal is to extract the single most high-yielding core trend without getting distracted by the filler data. Just breathe, scan, and isolate the reality of the physics. Now, what's really interesting about this slide is what happens when that mindful scan fails. Let's move to challenge 2, the imperfect answer. We're going to display a slightly flawed student paragraph on the screen right now, drafted earlier by Sam, who sometimes loses focus on specific command word parameters. Your challenge is to identify the exact sentence where structural discipline breaks down and marks are lost. As you look, keep in mind these top 3 explicit traps identified by Cambridge principal examiners. Trap 1, confusing cause and effect. We often mix up which force is driving the system and which is resisting, literally confusing a forward driving force with opposing friction. Trap 2, forgetting to check format and presentation, which bleeds away those beautiful method marks we just secured. And Trap 3, providing generic answers. This shows the examiner you've memorized a textbook, but you haven't actually applied your knowledge to the specific scenario sitting right in front of you. Look closely at the difference in methodologies here. I'm using my clean highlighter strokes on the screen to reveal the correct paths, detailing examiner compliance step by step. On the left, we have the generic approach. This flawed response relies on unstructured facts. It's writing down every single variation of Newton's second law without actually linking it to the specific towbar in the question. But look at the high-yield approach on the right. It is calm, it is structured, and it is explicitly linked. Every single point, every equation for tension or acceleration is tied directly to the unique weights and resistance forces of the given scenario. That is how you command the page. To absolutely guarantee we always land in that high-yield category, particularly when we're asked to evaluate a system's mechanics, we can rely on this precise 4-step formula for comparative analysis. 1. Identify similarities and differences in the system's forces. 2. Use comparative connectives in any descriptive answers to show flow. 3. Support every mathematical claim with direct evidence straight from your force diagram. 4. Draw conclusions on relative importance. For example, explicitly determining which net force ultimately dictates the direction of the system's acceleration. Follow these steps and your logic becomes bulletproof.
Section 5. Systematic Recipe Recap, your final polish.
We are entering the final stage of our deep focus session. On the digital notebook display, Alex and Sam are looking over their completed, flawless response paragraph, and you can see our focus meter maxing out at 100%. This is the ultimate directive for achieving higher-order assessment objectives. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence. We don't just calculate, we evaluate. We question the assumptions of a smooth, frictionless pulley. We justify why tension remains constant throughout a light and extensible string. This is the zenith of the exam flow. To maintain this supreme, serene mastery under the strict time limits of the exam hall, I want to distill this entire masterclass into 3 core focus pillars. First, the 3-step question scan, which is all about calmly decoding the prompt. Second, the marks per minute flow formula, which protects your timing. And third, the final polish review pass. As a final study strategy, create a custom mnemonic using the first letters of our core procedural terms: identify, apply, execute, verify, present. Building a personalized memory hack lets you instantly recall this exact procedural flow the moment you turn the page and see a complex diagram. It's your anchor. I want to leave you with this final, provocative thought to meditate on. How will you adapt this systematic framework to your very next practice paper? The next time you face an unfamiliar connected particles context, I want you to remember this exact feeling of calm, structural control. To keep this momentum going, make sure you subscribe to Ace the Exams. That's at Ace the Exams. Click that notification bell for future focused deployments. And right now, leave a comment below identifying the specific subject, tier, and target grade you're currently meditating on. Trust your process, take one last deep breath, and we'll see you in the next explainer.